Build a bubble-powered rocket from NASA's Space Place, www.nasa.gov. Build your own rocket using paper and fizzing tablets. Watch it lift off. How high does your rocket go? Suggestion: find a grown up to do this activity with you. Materials: paper, regular 8.5 by 11-inch paper such as computer printer paper or even notebook paper. Plastic, 35 millimeter film canisters. See hints below. Cellophane tape. Scissors. Effervescing, fizzing, antacid tablet, the kind used to settle an upset stomach. Paper towels. Water. Eye protection, like eyeglasses, sunglasses, or safety glasses. Hints: the film canister must be one with a cap that fits inside the rim instead of over the outside of the rim. Sometimes photography shops have extras of these and will be happy to donate some for such a worthy cause. Keep in mind, just like with real rockets, the less your rocket weighs and the less air resistance drag it has, the higher it will go. Making the rocket. You must first decide how to cut your paper. You may cut it the short way or the long way to make the body of the rocket. There is no one right way to make a paper rocket. Try a long skinny rocket or a short fat rocket. Try a sharp nosed cone or a blunt nosed cone. Try it with fins or without fins. Experiment. Here's just one idea for how you might cut your whole rocket from one piece of paper. For nose cone, use a jar lid or something like that to trace the shape. Roll this long piece around the film canister for the rocket body. Tape canister to edge of paper before you start rolling paper around the canister. Here are the basic steps. 1. Cut out all the pieces for your rocket. 2. Wrap and tape a tube of paper around the film canister. Hint: tape the canister to the end of paper before you start wrapping. 3. Important: place the lid end of the canister down. 4. Tape fins to your rocket body if you want. 5. Roll the circle with a wedge cut out into a cone and tape it to the rocket's top. Blasting off. 1. Put on your eye protection. 2. Turn the rocket upside down and remove the canister's lid. 3. Fill the canister 1/3 full of water. Now work quickly on the next steps. 1. Drop 1/2 of an effervescing antacid tablet into the canister. 2. Snap the lid on tight. 3. Stand your rocket on a launch platform such as your sidewalk or driveway. Stand back and wait. Your rocket will blast off. How does the pop rocket work? When the fizzy tablet is placed in water, many little bubbles of gas escape. The bubbles go up instead of down because they weigh less than water. When the bubbles get to the surface of the water, they break open. All that gas that has escaped from the bubble pushes on the sides of the canister. Now, when you blow up a balloon, the air makes the balloon stretch bigger and bigger. But the little film canister doesn't stretch, and all this gas has to go somewhere. Eventually, something has to give, so the canister pops at its top, which is really its bottom since it's upside down. All the water and gas rush down and out, pushing the canister up and up along the rocket attached to it. We call this wonderful and useful fact the law of action and reaction. The action is the gas rushing out of the rocket. The reaction is the rocket taking off in the other direction. In other words, for every action, there is an equal and opposite reaction. The rocket goes in the opposite direction from the gas, and the faster the gas leaves the rocket, the faster the rocket gets pushed the other way. Blast off. Real rockets work kind of the same way as the pop rocket, but instead of using tablets that fizz in water, they use rocket fuel. The rocket that launched Deep Space One on October 24th, 1998, had 4 different kinds of engines. Some pushes the rocket off the ground. Then some helped it continue its climb into space. Others gave the Deep Space One spacecraft its final push away from Earth. But all of them forced a gas to shoot out of the rocket, thus pushing the rocket the other way. Number 6. What is the main idea of the section? How does the pop rocket work? Use details from the section to support your answer. Number 7. The weight of the rocket is important because it impacts. Choose 2 answer choices. A. How high it will fly. B. The amount of time it will take to make. C. The level of air resistance. D. The amount of material you will need. E. How long it will take to blast off. Number 8. Which of the following occurs after putting on your eye protection? A. Cutting the paper. B. Taping the fins to the rocket body. C. Turning the rocket upside down. D. Asking an adult for help. Number 9. The author most likely included the photograph and the section blast off for 2 reasons. For what 2 reasons? A. To teach how to make your own rocket. B. To explain the job of the astronauts on Deep Space One. C. To show how real rocket launches work in a similar way. D. To tell a story of a real rocket launch. E. Provide a visual example of a real rocket launch. Number 10. Read the sentences. Which underlined word best helps the reader understand the meaning of the word blunt? Try a long, skinny rocket or a short, fat rocket. Try a sharp nose cone or a blunt nose cone. Try it with fins or without fins.